You'll hear a lot of terms. You'll hear terms like .NET Framework, .NET Core, .NET. So let's sort of initially just get familiar with all these concepts. Before we jump into any coding, let's understand what is .NET all about. And then once we know what is .NET all about, then it's easier to understand why we're coding in a certain way. Okay. Now, let me take you a little bit even before .NET. So before .NET started, this is typically a situation that you will have with any type of software. You'll have, multiple layers in your software where you'll have the database, you would have the front end, and you would have a middle tier, right? So the front end is where your UI will come in. The middle tier is where your business rules will come in, right? And the front end communicates with the middle tier, and the middle tier, of course, communicates with the database. So this is a scenario in any software that you develop. You break it up into different sort of layers or tiers, as they are called as. Now, when you're talking about specifically about Microsoft, before .NET, this was the scenario. For creating your front end, right? These were the popular choices that Microsoft offered you. Either VC++ or VB6 or ASP. Now, of these, VC++ and VB6, right, were used for creating desktop-based applications. And ASP was used for creating web-based applications. So when I say desktop-based applications, I mean that you'd be, running it by installing the software on your machine and then running it from there. A web-based application, on the other hand, of course, would be installed on the server and you'd be, accessing it from a browser. So these were the popular choices that were available at that time in Microsoft: VB6, VC++, and ASP. The middle tier, doesn't have any UI. Typically, there'll be code that's running. What we would call as business rules. Like, for example, if you have some data, what is the valid data? What can you do with the data? The functions, the storing into the database, all of this would go into the middle tier. Now, the middle tier in all Microsoft applications was created using a technology called COM. And here's COM, stood for something called as Component Object Model. So COM was the technology. In fact, COM is still prevalent today also. It's not just back then, but it's prevalent today also. So what COM did was it allowed you to create your software as a component that can be used by anybody else. And there was a certain hierarchy, there was a certain set of objects that you would be creating. So the entire set of hierarchy out there was typically referred to as a component object model. Now, any front end that you worked with could interact with any COM application, and that's what you would be working with. So COM was the most popular thing that you would be working with, because everybody, whatever your front end, would still be working with a COM application. And then, of course, the database could be anything. So database, we're not worried about. We are more worried about the front end and the middle tier. Now, in all of these, there were certain issues or there were certain problems that you face as a developer, right? So what were some of the issues that we faced as a developer? We had, if you were a VC++ developer, VC++ had the best of the features. Everything that you could possibly want from a language, it had. It had, it was object-oriented code. It had threading, it supported threading. You could do a lot of things with VC++. But the problem with VC++ was it was extremely, extremely complex and cryptic. Extremely complex. So writing code and maintaining code used to be not very easy. It used to be very, difficult to do that. Much more complex stuff that's happening. VB6, on the other hand, was very, very simple to use. Very easy to code in VB6. But the problem was it was not object-oriented and it didn't support threading. So you had one language which had all the features but was very complex, another language which lacks certain features, but was very simple to use. All right. These were the desktop-based applications. ASP-based applications or web-based applications, these were script-based. These was interpreted code, late-bound code, right? A combination of HTML and script. So this is very difficult to maintain and debug, and it was of course not object-oriented code. So web-based applications also had their own problems. Desktop-based applications also had their own problems. Now, the biggest problems were not so in the front ends, but were in this middle tier. What did we call the middle tier as? What was this being created as a COM component? And everybody was using the middle tier. Now, the middle tier, the COM component, these had certain major problems that developers faced, right? Now, there were a lot of problems, but the two major problems were something called as versioning of a component and deployment. So these are the two issues where developers would get stuck on. Now, to understand what happened, and it's relevant to .NET also, let's try and understand why this problem came up. When you create a COM component, you can't just copy it onto a machine. You have to install it in the Windows registry. Any COM component that you create has to be installed in the Windows registry. Now, when you install it in the Windows registry is a common area where all your software is installed. Okay. Now, a couple of things could go awry. First thing is, if you wanted to install another version of the same product, let's say you have installed version 1, and on the same machine now you want to install version 2. Now, some software is using version 1, some software is using version 2. If two versions coexisted on the same machine, these would cause problems for you, right? So this is what I mean by versioning. If you had two versions of the same component on the same machine, this could cause problems for you if you did not follow certain guidelines as a developer, right? So it's not that COM components had all COM components had problems. The problem was if as a developer you had not followed certain guidelines, then it would cause problems to you. Now, these are not rules, but these were guidelines. And the problem was that most developers did not follow the guidelines. And which is why when they tried installing it on a machine, it would cause you problems. So this was one major issue that developers faced, versioning of COM components. The second issue that they faced was deployment. As I said earlier, you couldn't just copy paste your code out there. You had to install it on the Windows registry. So when you're installing it on the Windows registry, there are a lot of things that could go wrong. First thing is that if there is an existing component, you have to uninstall the existing component and then install the new one. So while uninstalling the previous one, it may not get uninstalled correctly. And then other issues that could come in here. So there were a lot of nitty-gritty problems when you were working with COM components. Now, these are the two main ones that I mentioned. There are a lot of others that were there, which are minor ones, and I don't want to get into what is COM all about. Now, a COM component, physically, when you create a COM component, it is created as what is known as an ActiveX DLL file. Any COM component that you create is actually created as what is known as an ActiveX DLL file. So typically these problems that you were faced with in COM, there was a term associated with it called DLL hell. So why DLL hell? Because the COM component, one of the COM components is an ActiveX DLL file. And the problems that are associated with this are typically referred to as DLL hell. So this, I'm just giving you a quick summary of what the situation was before .NET came. All right. So problems in all possible things, in your front end as well as in your middle tier. Now, when Microsoft looked at these problems, they said instead of solving these problems individually, like what could be the problems, instead of, let's say, how do we make VC++ less complex? How do we add features into VB6? How do we make ASP run better? How do we solve the biggest problem of all, of COM DLL health? Instead of looking at these problems individually, they said we will look at these problems together and come up with a solution that targets all these problems. And that was the birth of the .NET framework. So the .NET framework came in because of these issues, right? And the .NET framework obviously addresses all these issues. It, solves all these problems that were there before. And, we'll see how it does that. Are we clear on this, everybody?
Yes, sir.
Yes, sir.
Yes, sir.
All right. Let's look at a few .NET features. So when you're working with .NET, remember it's a total break from the previous one. It's a entirely different, way of coding. So all code that you write in .NET is object-oriented code. Okay. Now, obviously, you're used to working with object-oriented code, but at that time it was a big deal because not everybody, not all software was object-oriented. So here in .NET, everything is object-oriented. .NET supports multiple languages. So the language that you would code with became a matter of choice. So at that time, for example, when .NET was launched, some people were coding in VC++, some coding in VB6, some on other languages. So .NET says you can code in any language that you want. There are over 50 .NET languages that you can code in. So which language to use for a programmer becomes a matter of choice. Okay, you are comfortable in one language. Let's say before .NET you were working in VB6, you can work with VB.NET. If you're working with VC++ in .NET, you can work with C#. So on and so forth. Some of you all might be, might have learned Python, for example. So now we're not doing this in Python, but you can write code for .NET in Python also. Some of you all are, let's say, coming in from maybe a mainframe background, not you, but some others. You can write code in COBOL also. You have variety of .NET languages that are available to you, right? Okay. Code in .NET would work on multiple platforms. Now there is an asterisk next to it, right? The asterisk indicates that conditions apply. So it's not, a blanket statement. We will talk about what are the, possibilities or what are the combinations available here. How does it work on multiple platforms? In what way it works? So all .NET code doesn't work on all multiple platforms. So we'll talk about this a little later once you've seen a few things out. Okay. .NET supports multiple project types. So you can create your web-based applications. You can create your desktop-based applications. You can create mobile-based applications. You can create a variety of different applications out here, right? .NET offers you much better security features and also improved performance, where .NET code works better and faster than its competitors, and obviously works better and faster than previous versions of Microsoft code also. It's not just Microsoft, earlier versions of Microsoft code, but even its closest competitor, Java, for example. .NET works much better than that, all right? And these are some of the key sort of advantages or features why you would want to use .NET, right? Now, when you talk about the .NET framework, right, there are different aspects that we'll be talking about. Let's start off by talking about something called the .NET framework. The .NET framework sits on top of your operating system. So which means that whatever is your operating system, there'll be the .NET framework has to be installed on top of that. And then the .NET framework then calls methods on the operating system, or in certain cases, it might directly work with the hardware also. Instead of, it might bypass the operating system and directly work with hardware in certain situations, right? But in most cases, it will be working with your operating system, right? Okay. Let's break this down further. The .NET framework that we're talking about, let's deep dive further into it and see what is there in the .NET framework. So to begin with, you'll be creating applications of different types. Remember, we said that there are different project types that you'd be working with. So there are different possible applications that you can create in .NET. I'll just read out some of them. You can create web applications. You can create Windows Forms as an example of desktop applications. So the application has to be actually installed on that user machine. You can create console applications, right? When you code in C, C++, or initially at least in Java, you see that dirty looking, black looking screen like the console app. So you can create those type of applications also out here, right? You can create services. You can create different types of services. So there's something called web services. There's something called WCF, which is Windows Communication Foundation, in which again you can create services, right? You have something, web APIs. You would have seen web APIs before, right? In Java or wherever else you're working with, other web technologies that you're working with, you would have been introduced to web API. So you can create all these type of services. You can create, different project types. Now, all of these actually don't make a lot of sense to you right now. I mean, there's no point in me just calling them out. There's something called as Windows Presentation Foundation, workflows, right? You can create ASP.NET MVC applications. So ASP.NET MVC applications is what we're going to be doing in our course. The focus is going to be on that, right? Web-based applications, basically. You can create .NET Core applications. Again, we'll be looking at .NET Core, right? You can create Xamarin. Xamarin is the mobile computing platform that we're not going to look at. Okay, and Windows services also you can create. So various different types of applications that you can create in .NET. One platform that's giving you multiple options out here. Now, irrespective of what you're working with, whatever applications that you're working with, you will need to use the inbuilt .NET classes. And these inbuilt .NET classes are available to you in something called as a .NET base class library. So the .NET base class library is, all the, I'll use the word here, assemblies, all right? And I'll explain that in a minute. So all the assemblies that, .NET provides are coming under .NET base class libraries. So an assembly, if you're, used to Java terminology, is like a package that you would create in .NET, in Java. So in .NET, you call it a assembly. And these would contain all the different classes that are available here. The assemblies that you create in .NET, if you notice, these have an extension of .dll. So there'll be multiple different files that you have out here, which you'll be working. We'll see these as we go along, right? So I've just listed 2-3 of them, but there are hundreds of these assemblies that are available to you, right? So any application that you're creating would require to work with the .NET base class libraries. Now, how do you write down the code? You would be, of course, writing down the source code in any .NET language. So we mentioned in the previous slide that there are over 50 .NET languages. And these different .NET languages can be, it's a matter of choice. You can use any of these to code different applications that you're working. Now, in this course, in the CDAC course, we're going to be doing C#. So C# is the most popular .NET language, and that's the one that we're going to do in our course. But there are other options also available, which we are not covering in our course. But you could write code in other .NET languages as well. Are we clear on this? All right. Now, after you write your source code, supposing you've written your source code, what is the next step after you finish writing your source code? What
We
do
have
you
to
do?
compile.
Compilation.
You need to compile, right? Now, to compile your source code, each language would have its own compiler. So, for example, if you're working with C#, C# has its own compiler. If you're working with VB.NET, VB.NET has its own compiler. If you're working with a different language, that each language would have its own compiler, right? Now, irrespective of which language and which compiler you use, that does not matter. Whichever one you use, at the end of compilation, after you finish compiling your code, you get an assembly. All right. I mentioned some time back that assembly is like what? In Java, it's like a package. So when you compile your Java code, you're getting a package. In .NET, what are you getting? You're getting an assembly. So an assembly is a unit of compiled code. When you compile your code, you're getting an assembly out. Right? The assembly extension can either be an exe or a DLL. So here we have seen examples of what? Of assemblies which have an extension of DLL. You may also have assemblies which have an extension of exe. Right? So we'll talk about what is the difference between exe and DLL in a short while. But before we do that, let's focus on what else is there in the assembly. Now this assembly, just like you did in Java, just like what you've been doing in Java, is in bytecode format. Okay. So when you compile your Java source code also, what are you getting? Your format of the code is in bytecode format. But in .NET, you will not call it bytecode. In .NET, don't call it bytecode. .NET has given a name to its bytecode. And in .NET, this bytecode that you're getting in the assembly is called as IL, or intermediate language. Right? So what is the format of code in the assembly? It's in IL format. IL. IL here stands for intermediate language. Okay. This has other names also. It is also called by other names. Instead of IL, it could also be called as MSIL. Any guesses what MS would be?
Microsoft.
Microsoft Intermediate Language. MSIL. Or it could also be called Common Intermediate Language, or CIL. So all these words mean exactly the same. Either IL or MSIL or CIL, all of these mean exactly the same. Are we clear on this?
Yes, sir.
All right. Okay. So what have we said so far? When you compile your code, you're getting an assembly. An assembly is in IL format. The format of the code is in IL format, right? And we said the assembly could either be an exe or a DLL. So what is the difference between an exe and a DLL? An exe would be an assembly which has an entry point defined. An exe is an assembly which has an entry point defined. What do I mean by entry point? Entry point meaning that there is a main function in there which can start off directly. So you can run this assembly on your own. You can run this assembly directly. A DLL, on the other hand, does not have an entry point defined. So which means you can't run that assembly directly. You can only call code from that assembly. It will contain classes. You can only call code from those classes. You cannot directly run that. Okay, so that's the difference between your exe and your DLL. Okay, we'll be seeing both. When we are coding, we'll be seeing both. Are we clear on this, everybody?
Yes.
All right. Now coming back to the IL. When you compile your code, you're getting IL. IL is like bytecode in Java. Now this bytecode cannot be run directly. This IL cannot be run directly. Right? See, when you wrote code in C++, and when you compiled that code, you got code that can run directly. When you wrote code in C++. So that sort of code which can run directly is called as native code. What is native code? Native code is code that can run directly. You don't need any extra, transformations on that code to run that code. It's in machine code format. It's something that can be directly run out there. And the term here used to describe it is what is native code in C++ when you compile your code. So here, before you can, run this code, this IL of yours needs to be converted into native code before it can run on that machine. Right? And to do that, to run your code, you have in .NET something that's like the heart of .NET, something called as the CLR. The CLR here expands to the Common Language Runtime. Right? The CLR is used to run your .NET. Any code that you're running in .NET is going to be run by the CLR. Okay. Now, before we go any further into the CLR, why the name CLR? Why Common Language Runtime? What do you mean by runtime? What do you understand by runtime? Yes.
Provides an environment.
Correct. The environment that is going to run your code. And why Common Language Runtime? Why Common Language Runtime?
So
it is common for all.
Any language can.
So because source code can be written in multiple languages. So it can.
So irrespective of which language you write code in, on compilation you're getting IL, and the runtime for this is the same. So you don't have a different runtime for C# and a different runtime from VB.NET. The runtime environment for this is exactly the same, which is why Common Language Runtime. Okay. Now the CLR has multiple functions. CLR performs multiple functions. So we're going to first have a look at what are the different functions of the CLR. Okay. First function that we are looking at is JIT compilation. JIT here expands to just in time. Just in time compilation or JIT compilation is the process of converting IL into native code. Remember, your code is in IL format, and we said that to run your code, you need what? You need native code. So the process of converting this IL code into native code is carried on by the JIT compiler. The process is called JIT compilation, but it's being done by whom? By the JIT compiler. The JIT compiler is also called as a jitter, J-I-T-T-E-R, jitter. So jitter is short form for JIT compiler. Okay. JIT compilation converts dash code to dash code. JIT compilation converts dash code to dash code.
IL code into
IL
native
code
code.
into native code.
Correct. IL into native code. Now, why is it called just-in-time compilation? Why is it called just-in-time compilation? Let's assume this is your, code. Remember, main is the startup point of your this thing. I'm not writing code. I'm writing more of pseudo code, but it's not syntactically correct. So let's assume you had function 1. right? So let's assume you had some functions written here, function 1, 2, 3, and so on up to, let's say, function n, where n is a large number. Okay. Now, if you wanted to call code from main, let's assume this is what I'm doing, func1, and then I'm calling, let's say, func2, func3, and func1 again. Right. Now, when you run your code, the first thing that would run, the first function that would run there would be the main function. So what it does is it takes this main function and converts that IL only for the main function. It converts that IL into native code only for this one function. So you might have 1,000 functions in there, but it's only doing it for the function that you're calling first, main function. Now, when does it do this? It does it only when main is called. Okay, so when main is called at the start of your code, that's what's happening. Now, main itself is calling function 1. So what will it do when function 1 is called? What will it do when function 1 is called? Yes.
So it will convert IL to native code for function 1 only.
Correct. The just in time indicates that it will only do that for function 1. Right? Now, where is this getting converted? This is not a physical file. This will be in memory itself. So the native code that's being created is in memory itself. You're not getting a physical file. All right. Now, when function 1 is over and then when you call function 2, at this time, it will again JIT compile function 2. Similarly, when function 3 is called, it will first JIT compile function 3 and then call it. Now, after 3 was over, if you look at this code snippet of mine, what am I doing again? What are we calling again?
Calling again function 1.
Function 1 again, right? So when you call function 1 again, your JIT compilation will not happen out here. JIT compilation has already happened. That function is already in memory. You already called it on an earlier place. So the second time that you call the function will not be JIT compiled again, but it will use that code that is already there in memory and it will call that. So every time that you call the function, second time or later, the function runs faster than if you call it on the first time. First time you call the function, there is always a slight overhead of JIT compilation. Are we clear on this? So hence
Yes, sir.
the term just in time or JIT compilation, only when needed. All right. What if there were 1,000 functions and this is the code that I was calling? How many would get compiled into memory in this code snippet? Suppose there were 1,000 functions. How many will get compiled actually? JIT compiled?
3.
Only
Only
that.
the 3 functions.
Yes, sir.
I'm assuming function 1, 2, 3 are not calling any others, but this would be the only 3 functions that will be JIT compiled. Are we clear on this?
Yes, sir.
All right. Now, one of the aspects that we talked about in .NET, we said that it gives you much better performance over previous code that ran or any of its competitors or whatever. So that's one of the key areas out there. Now, if you compare it with, let's say, code that you wrote in C++, right? In C++, how did you work? You actually wrote your source code, and then after writing the source code, when you compiled it, it immediately got compiled into, of course, first it got converted into object code, then it got linked, but final output that you got was an exe, which finally was, native code format. So my question to you would be, if I had .NET code that was running, and if I had to compare it with let's say C++ native code, which would work faster and why? Which would work faster and why?
So C++ would work faster.
Why?
So because it is already compiled,
Into native.
yes, it is already compiled to native code.
right? So this is what conventional logic says. This is what regular logic says. But even though we are talking about, it's a two-step conversion and whatnot, .NET code still works faster than native code. So how is this possible? How is .NET code still working faster than native code? There are a couple of reasons for this. First reason is that even though there is a JIT compilation is an overhead, it is not that big an overhead. So there is an overhead, yes, but the overhead is minuscule because it is already in, in IL format. So converting it to native code is not very difficult, is not going to take a lot of time. So there is an overhead, but there's a minor overhead. Now, where does it score? Where does it, become faster, or where does it work better? The first thing is load times. If you had a library which was, native code library, how much time will it take to load your functions? Supposing there are 1,000 functions in there. What is going to happen there is all 1,000 functions will be loaded into memory. But here, in case of .NET code, what would happen? How many functions are loaded into memory initially?
The function which are called.
Only one.
Function which is
So initially only one, no? Initially only main. So load times are much quicker, much quicker compared to a library that had a lot of functions out there. Secondly, the real, performance benefit or the kick that you're getting in the performance is coming from the fact that the code to be compiled or the code to be converted into native code is being done at runtime, and at runtime you know what type of processor you're running it on. Okay, so now try and understand this logic. When you write native code, you might be running it on different devices. Agree? Native code, that any code that you're writing might be run on different devices. Now you cannot make use of some features of one particular type of processor. You cannot do that. Why can't you do that? In native code, why can't you make use of features of a particular type of processor, let's say? Why can't you do that? Supposing a processor has some feature, I'm saying native code cannot make use of that. Why am I saying that? Yes,
It will become processor dependent.
correct. Because then it is dependent that you will run code only on that type of processor. But you have to give out code that can run out on every processor on different devices. So what you end up doing in native code is you end up taking the lowest possible thing. You don't take up the one which has the highest possible thing. You take up the lowest possible features, because then you're sure that your code will run on all devices. But that is not the case when you're JIT compiling your code. When you're JIT compiling your code, you're JIT compiling it at runtime. So at runtime, you already know what type of processor your code is running on. And the JIT compiler, it's not just actually, .NET doesn't just have one JIT compiler. There are multiple JIT compilers. So depending upon what type of processor you're loading or running on, the CLR loads that particular JIT compiler. And it gives out code that is optimized to run on a particular processor using features of that particular processor. So that is where it gets the performance kick. Because you're not giving out code that will run with the minimum thing. You're giving out code that will give you the maximum features. So all the slight overhead that you had of JIT compilation is overcome because of first loading your assembly quicker in memory, and secondly optimizing the type of code that would come out of the JIT compile. So that is where you get the performance benefit. Right? Now it's very easy to argue one way or the other. Sitting here, we can argue one way or the other. No, how will it be faster? I'm sure native code will run faster. But how do you settle the argument? How do you know for sure that what is the correct thing? Whether .NET code is faster or whether previous code is faster? How do you settle the argument?
By actually running the code.
By actually doing performance testing. And performance testing has shown that .NET code runs much better and much quicker and much faster than any of its, competitors, you want to call it, or any of the previous code that you wrote down, whatever you're doing. Are we clear on this? So this is why we are sort of harping on that performance aspect. All right. So that is one function of the CLR. The CLR is responsible for JIT compilation. All right. Let's look at a few of the other things that, other functions that the CLR performs. All right. So I've listed out a couple together. The CLR is responsible for memory management and for garbage collection. So what is memory management? When we talk about memory management, what are we talking about here? We're talking about initially when the program starts off, loading the program into memory, deciding where in memory it should be loaded. Should things be created on the heap, should be created on the stack, whatever. As your code goes along, you will need more objects that you're creating. So allocating memory for that. All of this, loading and unloading assemblies as required. All of this is to do with memory management. All of this is being handled by the CLR. Okay. Now, one aspect of memory management is releasing memory when no longer required. So freeing memory when no longer required. When your object, you're finished working with this, the object is no longer required, then freeing memory. Now, this particular aspect of freeing memory is handled by the garbage collector. So the garbage collector is responsible for garbage collection. And what do I mean by the word garbage? What does the word garbage here indicate? It indicates garbage memory. So what is garbage memory?
Unused.
Give me a better word.
Memory that can't be accessed.
Correct. Memory that is now no longer be referenced by anyone. Instead of saying unused memory, you say memory that is no longer being referenced by anyone, that cannot be accessed by anyone. Right? Let me give you an example of that. Let's say, for example, again, I'm not writing real code. You can think of this as pseudocode. What is O? What is O out here? Assuming class 1 is the name for class, what is O?
Reference
name.
Right. So O is a reference of type class 1. Right? And somewhere later, I might do something like this. O is equal to new class 1. Right? So what is new class 1 here?
Object.
Object of type class 1. Right? Instance or object. And O is now pointing to that. O is now referring to that. Okay. Now, somewhere later in my code, if I did O is equal to null, that means now at this point, O does not point to this block of memory. Right?
Yes, sir.
So who's pointing to this block of memory now?
No one.
No one. So such memory where no one is pointing to it, no one is referring to it, no one is referencing this memory. Such memory after this line obviously would be called as garbage memory. Right? Now, freeing this garbage memory when should it be freed, and when should, when you're saying that you're no longer accessing it, when should this happen? Earlier, before .NET. And now when I'm saying before .NET, I generally compare it with C++. So in something like C++, for example, freeing of memory was handled or was decided by the programmer. So the programmer was responsible for firstly allocating memory and secondly deallocating memory. So in, for example, in C++, instead of O is equal to null, you might write a statement like this, delete O, for example. And on this line of code, you're sure that that block of memory would be released in C++, right? Now in .NET, when you do O is equal to null, freeing that block of memory is not the job or is not the responsibility of the programmer. But instead of that, freeing that block of memory is handled by the garbage collector. So the garbage collector is responsible for freeing the garbage memory that is no longer being accessed. Are we clear on this, everybody? Now,
Yes.
let's try and
Yes, sir.
understand this. Let's try and understand this with a parallel example. So you may be knowing of garbage collection. You can give me better answers based on your prior knowledge, right? So I'm going to give you a alternate scenario. Okay. So you have to imagine this. It's not really happening, but you have to imagine this. Imagine you were right now physically in the center. So you are either in Kharghar center or in Juhu center. Right? You're physically sitting out there, right? And generally at the end of every session, maybe you have a couple of hour session, then you generally take a break, right? So let's assume that after a short while, you will be going in for a break, right? Now, when you go in for a break, CDAC, let's say Kharghar or Juhu, arranges for tea or coffee for all of you. Of course, you have to pay for it, but they do arrange for the tea or coffee for you all, right? And now there are two possibilities that exist. One possibility is, let's assume you're using those reusable cups that you have to wash and keep back, and then you can reuse them. You don't it's not like a single-use cup. You don't mess up the environment. So you are going to take up a cup. You're going to have your tea or coffee, all right? And after you finish this cup of tea or coffee, you need to wash that cup again. Okay. So this is the scenario. This is the scenario that I'm asking you to imagine. Now there are two possibilities that exist. All right. One possibility is that after you finish your tea coffee, you yourself have to wash your cup and keep it back. All right. That is one possibility. Now what might happen is, if you're doing that, then it takes a lot of time. So imagine 100 of y'all, 100 plus of y'all standing in line to take the tea and coffee, then finishing the tea and coffee, and then again standing in line to wash the cup, right? So that will take a lot of time. Okay. So to avoid that, and then when the faculty asks you why you left late for the lecture, you'll say, oh, I was washing my cup of tea. Okay. So to avoid this scenario, what CDAC has done is it has appointed a teacup collector, right? Now the job of the teacup collector is to go around and then see, remember, you might not be the only ones drinking tea or coffee. There might be other people from CDAC office coming in, taking a cup of tea or coffee. And let's assume you're allowed to go back to your place, wherever. Let's assume you're allowed to bring it back to the lecture room also. You're not, but let's assume in this imaginary situation. Or people can take their teacup coffee and go on to their desk. So let's say there is this teacup collector who has been assigned. And what is this job of the teacup collector? He has to go and collect the teacups. And, then wash them and make them available again. Okay, so this is his job. This is what he has been asked to do. Now he has been told to work in a certain way. He has been instructed strictly that if you get up from your place, okay, if you get up from the place, you will not go and get only 1 cup, 2 cups and come back. You have to go around all over CDAC. And wherever the cups are, which are not being used, of course, you have to gather all those cups and come back. So this is what has been told to him. You can't get up only once and go get 1 cup and come back. You have to go and get all the cups and come back. All right. So this is the scenario. So what is the scenario? You are all having cups of tea or coffee. Teacup collector assigned for that. Teacups can be in different rooms. Right? Need not be in one room. They can be in different rooms. He's been told what? If you get up from your place, you have to go and get up and get them from everywhere. Right? This is the scenario. Now my question to you is this. When should the teacup collector get up from his place to go and get the cups of tea or coffee? When should he go and get them? At what point should he go and get them? So you can call out your answer. I'm not saying yes or no. I just want to hear your different possible answers that you are giving. Yes.
So one has finished drinking.
So when one person has finished drinking his or her cup of tea.
When you think
I'm
no
not saying
more
yes or
cups
no.
are available. When no more cups are available to
Okay.
give someone else.
All right.
Sometime after the break is over.
Sometime after the break is over. Okay.
Sometime we have to set up some threshold of limit, like according to our capacity.
Okay. So what you're saying is don't wait for them to get over.
Yes, don't wait to get overload.
Wait for maybe some certain number to be reached and then go and pick it up.
Yes.
Okay. I'm not saying yes or no. I'm just listening to your suggestions.
When someone is not holding the cup in their hands.
Okay. Who gave this answer?
Sir, I am Raghavendra Joshi.
Okay, fine. Right. Anything else? Any other different answers? Other than the
At
same, then
regular-
no problem. Yeah.
Regular intervals means half an hour, 1 hour.
Every half an hour, 1 hour, whatever. Okay. Is that it? Any more?
Certain percentage of memory has cup has been used.
What memory? We are talking about teacups here.
Cups, sir. Certain cups.
So that's what somebody said, na? Some threshold being reached, some level being reached, right? So that's similar to the earlier. All right. So I've received different outputs. Let's discuss different suggestions that have come in. In no particular order, whatever I remember, I will tell you. One suggestion was that when I finish my cup, he should come and take it. So first thing is he going to follow you around? Okay, have you finished? Have you finished? Have you finished or no? Finish fast, finish fast. Is he going to do that?
No, sir.
Not an efficient way of doing that. And it's not just you, there are so many of you. He'll go mad trying to figure out whose cup is over. Right? So that cannot be the right way of doing it. Secondly, somebody said that after a certain interval of time, right? Now, in this certain interval of time, how do you define the certain interval of time? There might be a period of time when a lot of people are coming to have their tea and coffee. And there might be a period when it's relatively free, for example. Nobody's wanting to have it at that time. So it cannot be after a certain fixed interval. It cannot be that. Okay. Also, what might happen is that if you're keeping fixed intervals, in between the cups might get over. So not a good way of doing that. Then somebody suggested, after the break is over, right? Now remember, you all are not the only ones drinking tea and coffee. Your batch is just one of the batches out there, right? There could be other batches running, other people working out there. So why should you wait for your break to get over? There might be people coming in during the whole day. On a given day, if there's a lot of portion to be completed, I might not give you a break also. Yeah, quite possible, no? There is a scheduled break between 12 and 12:30. But I said today, no, we have to complete a lot. So no break today. We are going continuous. What if I do that? Yes. So you can't be relying on, fixed timings, regular intervals. You can't be relying on that. Also because in that fixed time or regular intervals, the cups might get over. So we look at the other two options. Somebody said when the cups are over. So don't wait for the cups to get over, because then assuming he goes and collects the cups back again, then during that time, people are still waiting for a cup. So the best possible solution could be when you reach certain number of cups. Now, what number of cups, that is open to debate. How many cups? Supposing there are 1,000 cups there. Okay, when it comes down to 100 or when it comes down to 200 or when it comes to half or whatever, that limit can be varied. That doesn't matter. But typically when you find that number of cups are going less, when they're going low, and what limit, now that can be figured out. Are we clear on this, everybody? So that would be a best way. Now, obviously, we are not just talking about the teacup collector. We are talking about the garbage collector here. So the garbage collector here now, instead of a teacup, think of as a block of memory that he has to collect. So when should the CLR call this teacup collector or garbage collector? Sorry, not teacup collector. When should the CLR call this garbage collector? When memory is going low. Otherwise, consider this. Let's say there is plenty of memory on modern, servers and your laptops that are quite powerful. There's plenty of memory available. Let's say you free one block of memory. It's no longer being referenced. Now, by calling the garbage collector at that time, you're not speeding up the system. You're actually slowing it down. Now, why are you slowing it down? Because the garbage collector is a thread that's running. So while that thread is running, the CPU is going to be busy doing what? Busy doing garbage collection. And any other code that needs to run will have to wait until that is over. So if there is plenty of memory available, there is no need to call the garbage collector. The only time you want to call the garbage collector is when memory is low. It's like saying, somebody said, when I finish my cup of tea. So now let's say the teacup collector gets up. Now, what has the teacup collector been told? Don't just get up and go to one place. Go and get it from where? From entire office. So assuming a session is going on and somebody finishes drinking tea, what will this guy do? He will not just collect that cup, but he will come into our session. He'll come into our training and he'll say, Arey, I want to collect that cup of tea that you had some time back. So would that speed up my session or would it slow it down?
Slow it down.
Slowing it down, because while he's collecting the tea, if he's going around saying, Arey, chai do, cup do, I can't be carrying on with my session that time, right? Are we clear on this, everybody? So this garbage collection, which is handled by the CLR, when would the garbage collector run? When would the CLR call the garbage collector?
When we are done with our execution.
No.
Once the memory is low.
When the memory is
low.
going.
Whenever there is
When the
When
memory.
you're done with your execution, when you're finished with your execution, there are other programs that are also running. No? So why should it come and collect your memory if there's enough memory out there? Let's say our class got over. Should he come out there and collect our cups? What has he been told? He's been told if you get up, you have to go around everywhere. So if he's going to come and collect our cups, he's not going to only collect our cups. He's going to collect all the other cups that are available everywhere else. Is that speeding up work or slowing it down?
Slowing it down.
Slowing it down. Imagine there's a board meeting going on. All the top CDAC brass is sitting down there. Our session gets over. He goes into their meeting saying, "Arey kab do kab." Are you getting what is happening here?
Yes, sir.
So when would the garbage collector run? Simple answer. When memory is low. Otherwise, you don't need it. No? I'm just saying, supposing you have 10,000 cups. 3 cups are used. Should it matter?
No, sir.
Should it matter? No, no. There are enough cups. If somebody else comes, enough cups are available. But yes, when it goes down below a certain range, and that range will be decided by the CLR only, not by us. When it goes below a certain range, that's when the garbage collector will run. Are we clear on this, everybody? Till then, don't worry. Clear?
Yes, sir.
Yes, sir.
Okay. Now, why should it matter to us as a programmer when the garbage collector is running? Why should it make a difference to us? It makes a big difference to us because it changes the way in which we are been writing code all this while. Okay, I'll give you an example. Let's go back to this code. And let's assume this was the .NET code that I had written. So there were some lines of code here, and there were more lines of code here. Okay. Right. My question to you, let's see whether you can answer this well. My question to you is, listen to the question and answer, specifically to the question. What is a constructor? What is a constructor?
Constructor is a method with the same class name.
Correct. Well said. That is answering my question to the point. It's a special method having the same name as a class. Next question. When does the constructor get called?
When we are creating the object.
When we instantiate an object, when we create an object of that class, right? Third question. What do you typically do in the constructor?
Or we are
Initialize non-static fields.
Correct. You initialize whatever values that you want to have for the initial object, right? Well said. Well done. Next question. What is a destructor? What is a destructor?
Deallocating a memory.
I'm asking you what is a destructor. I'm not asking why are you using it.
Destructor is a special member function which has a there we with a tilde.
Tilde. Tilde is the name of a girl. Tilde.
Tilde. There we use a tilde for deallocate the object.
All right. So it again similar answer. It's a special function having tilde and the name of the class. Right. That's a destructor. Next question. What do you use a destructor for?
To deallocate the object.
Constructor.
What do you use a destructor for?
Free the memory.
What memory?
For to release the resources.
That is what I was looking for. So it's not releasing the memory of the object. It is releasing the resources that the object is holding. There is a difference. So if, for example, if maybe you have opened a file in the constructor, that file is a resource. In the destructor, what might you do? You might close that file. Correct? Or if you opened a database connection in the constructor, in the destructor, what might you do? You might close that database connection. So you're releasing the resources held by the current object. Right? Third and most important question. When is the destructor called? When is the destructor called?
At the end of execution.
At the end of the
When object goes out of scope.
We have to call destructor manually. Constructor called automatically.
When is the destructor called?
When we need to like remove the resources or delete the resources.
No. When is the destructor called?
When the program is terminated.
No.
When the object need not be used again.
No.
Sir, it gets called automatically before program.
No.
When the object is get out of scope.
No.
Sir, when the object no longer needs that particular resource.
No.
When memory is less.
Completion of execution
No.
of program.
I was about to say yes, but you first part you started correctly but ended wrong.
At the end of function.
No.
When we have to empty the memory.
You all don't know the answer.
At the end of constructor. If constructor.
When you delete something,
Okay.
destructor call.
When memory is for that object is finally released. The answer is when the memory is released. That's when the destructor is called. If you have an object, when you allocate memory, what is happening? Constructor gets called. When the memory is released, that's when the destructor is called. When you release the memory, just before the memory is released, the destructor gets called at that time. But the trigger point is what? Memory being released for that. Are you getting all of this?
Yes.
All the answers that you gave me are not accurate. You're giving me roundabout. Around this time it will happen. The actual answer is what? When is the destructor being called? When memory is released. Somebody gave me an answer, we have to release it explicitly. But when is it getting called? When it's being released, that's when it's getting called. What you do is not causing it. When memory is being released, that's when destructor is being called. Understand?
Yes, sir.
All right.
So,
Now,
sir,
yes.
first garbage collector is called and after that destructor is called.
So that's what I'm coming to. That's exactly what I'm coming to. So now my question to you is, if you look at this code, on which line of code is the destructor called?
6, 5.
Yeah, read out the line. What is that? Read out the code on that line. This line is what you're saying?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
I'll repeat my question. On which, in this code, where is the destructor getting called?
O equals to null.
I'll go back to my previous question. When is the destructor called? When is the destructor called? What is the correct answer to that?
After the
memory is being released.
When memory is released.
Yes.
So on which line of code in here is memory released?
At last line.
It is not. It is not.
Nowhere, sir. Nowhere. Nowhere. We can't predict, sir. Actually.
Nowhere. Why not? Why are you saying nowhere? You're the correct. You're giving me the right answer. Why are you saying nowhere?
Because, sir, we
Because
don't
the
know that the
object
memory
is
is full or not.
So the
So
memory is released when the GC runs, when the garbage
Yes,
collector
sir.
runs. Yes or no? Just last
Yes, sir.
10 minutes we are talking about that only, no?
Yes, sir.
Yes, sir.
And GC
What
runs
is-
only when memory is about to full.
Correct. When does the actual memory being released? Who's doing that job of releasing the memory? The garbage collector. Agree or no? I mean,
Yes,
let's
sir.
go back one step if you're not clear about this.
Yes,
We
sir.
said that the garbage collector is being used to release the memory. When is the garbage collector running? When is the garbage collector running?
When some
The
threshold is
memory
reached.
is
When memory is
getting
low.
low.
When memory is low, when some threshold is reached, when memory is low. Are we clear on this, everybody? So on which line of code out here can you say with certainty that memory will be low?
No,
sir, we
No,
cannot
sir.
predict.
No, sir, we cannot.
You don't know. You don't know, no? Yes or no?
Yes, sir. Yes, yes.
Okay, so let's put this together. We are saying that the destructor is called when memory is released. We are saying that. Correct? Second thing we are saying is that memory is released when the GC is run. Third thing we are saying, GC is run when memory is low. Fourth thing we are saying is we don't know when this would happen. So when would the destructor be called? I'll ask the same question again. When will the destructor be called?
After when GC runs.
So we can't predict.
We don't know. Why are you changing your answer? If you're agreeing with all my previous statements, and logically your answer should be that we don't know. Don't you all link the statements together, or you all are just saying, we'll accept this statement without thinking about it. I'll repeat what I'm saying. I'm saying destructor is called when memory is released. Agree?
Yes, sir.
Yes, sir.
Memory is released by the garbage collector. Agree?
Yes.
Yes, sir.
Yes, sir.
Garbage collector is controlled by the CLR. CLR
Yes, sir.
calls the garbage collector when memory is low.
Yes, sir.
Yes.
So when will the destructor be called?
We don't know, sir, because we
When
don't
memory
know.
is low, when the GC is running. Now we don't know where it's happening on this line of code. So how can you give me with certainty, you know, it'll be on this line or that line or this line or that line? We just don't know, plain and simple. We really don't know. Are we clear on this, everybody? So if we don't know when that code of mine could run, if we don't know when that code of mine could run, there is a possibility, that it might, you know, I want it to run here. A lot of you initially gave me this answer that I want my destructor to run here, but it's not going to run on this line. It could run maybe 2 seconds later. Agree or no? Or 2 minutes later, or 2 hours later, or 2 days later, or 2 months later. I just don't know when this would run. So how does that affect me as a program? How does that affect me as a program? Yes.
So we can't release the resources.
Correct. What are you writing in your destructor? You're writing code to release the resources. And now you're not sure when this code will run. It will run at some point. But at what point you don't know. So therefore, in .NET, it is recommended and it is suggested that you should not write any code in a destructor. Do you agree with the statement that you should not write any code in a destructor?
Yes, sir.
Yes. Why not?
Because we don't know.
Because we don't know when it will be called.
Exactly. Because we don't know when it will be called. So why do you want to write some code when you're not sure about this? So that's a big change from the way in which you're thinking. Are we clear on this? Yeah, go ahead and ask the question. If you're raising a hand, just ask your question.
Sir, we have read that we can, like, this is the bad idea to release resources in GC. So that's why we have read in Java that you can release the resources in finary block, or as we can write sc.close, as in for sc as in scanner. If we open a scanner object, so we can write scanner.close, something like that. So like how does that work then? If we are not able to release the resources, how does that work?
The point being that any code that you write in a destructor, will run, but will not run at a given point of time, will run when the GC runs. So
Yes, sir, we
here,
cannot predict it.
yeah, so we don't know when that will happen. So here, you should not write code in a destructor. Let's start with that statement. Now, obviously, it does not mean that you should not write code anywhere at all. You have to write code somewhere else, right? So you don't write it in a destructor, that's okay. That's what they're telling you, don't write. So then it comes to the next question. Okay, then where should I write that code to release that resource? Whatever points you mentioned, like, for example, if you'd like to close something or release something, where do you do that? So what is suggested is you use a function called as dispose, which is part of an interface called iDisposable. And any code that you would have normally written in a destructor instead now should come into your dispose method. All right. So that is what is the suggested way of going about it. Okay. And that's what we will be doing as well. Right. Not immediately here, of course, once we see a little bit of code, but just to draw your attention to the fact that we will not be writing code in a destructor. Are we clear on this, everybody?
Yes, sir.
Okay. Can we write code in a destructor? Can we? Can we?
Yes, sir.
Yes, sir.
Yes.
Should we?
No.
No.
Can you jump off the 25th floor of a building? Can you? Can you?
Yes.
No, sir.
Yes.
Can you?
Yes.
Yes.
Yes,
Yes,
sir.
sir.
You.
No.
No, sir.
And definitely not in my lecture. Okay. Because of the .NET lecture, you should not jump off in any case, but jokes apart, the point is the destructor is there as part of a language construct. As part of the language allows it. But in .NET, don't write any code in a destructor. Instead, write it in a function called dispose, which is part of an interface called iDispose. So once we are a little further ahead in our code and we have seen interfaces, then we will, try this same concept that we are talking about here. Are we clear on this? Okay, this feature of, the dispose, you're not knowing when the dispose will, not the dispose, of the destructor, not being known when it will be called. In .NET, there's a term associated with it called non-deterministic finalization. Non-deterministic finalization. What does the word finalization mean? Finalization is?
It is a method which is called.
Finalization in object-oriented terms means freeing of, your memory once you don't need it. Right? Freeing of that object is called as finalization. What does non-deterministic mean? Non-deterministic. One in English, what do you mean?
Which is not, which we can't determine.
Correct. Which cannot be determined, which is not known to us. So finalization occurs at a non-deterministic point, right? And therefore you follow this other option available out here. Are we clear on this, everybody?
Yes. Yes, sir.
All right.
Yes, sir.
So,
Yes.
so what happens when we are calling the destructor explicitly in our course? Will it wait for the garbage collector to work, and like, how does that work?
So if at all you are calling the destructor explicitly, that means it's like calling a function. But that is not the role of the destructor. No? The destructor is a function that should get called automatically. You shouldn't have to wait for it, for you to call that destructor. Which is why they've given you the alternate function. So they're asking you to write code in a dispose method and call the dispose method explicitly whenever you want to. So that's the mechanism that they suggest.
Okay, sir.
Correct. We'll see more of this once we are in the code. At this point, to talk about it is too premature. we'll discuss more why dispose, what is this iDisposable, why it's in an interface, what is the significance of that. All of that we'll see once we try out a little bit of code. Okay. All right, so this was the one of the functions of the CLR. I'll be sharing a book with you all, ebook with you all. All right. Now, I'd like you all to read up on, okay, generations in garbage collection. So do make a note of it. Generations in garbage collection. So what that talks about is which objects are first taken for garbage collection, or what happens if the object is not garbage collected on the first go. Then how does it work, and how does the garbage collector work specifically? What is the logic of the garbage collection? So I'd like you to read up. I can't possibly be talking about everything in detail, otherwise we'll just be I have to finish this portion in a certain number of days. I always have a fight with CDAC. Give me more days, and this is no, take only so many days. So read up on this, and if required, I might ask you questions on that also. All right, let's take it forward. One more feature of the CLR is app domain management, or app domains, or app domain is a shorter word for application domain. So application domain management, or in short, app domain management. Let me explain this with an example. Okay. Normally, when you run an application, any application, let's say app 1, I'll call this. This application runs within a process. Right? So just to give you an example, let's say I run Excel. Okay. So if I run Excel, actually I got a couple of other files also open out there. So there are actually 2 instances of Excel running. And if I take you into the task manager, right? If you take you into the task manager, you'll find that there are 2 instances of Excel running here. Okay. So these are your applications, which you have started. Now, every application runs in a process. So what you're looking at here are the different processes out here. So every application that you start is starting off a new process, right? Now, the process space allocated for that application is a lot more than the application needs. The application actually requires a smaller part of the process space, but there's much more allocated for it. Okay. Now, what would happen is if you run multiple applications, similarly, let's say app 2 and so on and so forth, right? Each application would be allocated a process space, lot larger than what it actually requires. Right? Now, what if I keep doing this? Don't make me draw more, right? My drawing is very good, but don't make me draw more. What if I keep doing this and keep launching multiple applications? What might happen at some point of time? What might happen?
Low memory or memory
correct
kind of finish.
So you might run out of memory because there's not enough memory to start off a new process. Okay. Nowadays on powerful laptops, you won't find this situation, but earlier, maybe 10 years back, 15 years back, if you ran even maybe 15-20 applications, at some point your operating system actually tells you that not enough memory to run these applications. Please close some processes and start off again. Now you may not face that problem anymore. So process space is taking up too much of space. Application doesn't require all of that. So an attempt was made. Can we try doing this? What if we can launch multiple applications in the same process? What if we can do this? What would happen if we did this? What will be the advantage, obvious advantage?
That extra space will be utilized.
Correct. You will be not requiring as much space as you would if you started off in a different process every time. So something like this was tried and it was successful also. It was, you could do that also. In fact, sometime back I mentioned something called ActiveX DLLs. All right. So these ActiveX DLLs use this concept out here, wherein they would run in the same process as the application that is calling them. But these were very unstable. So what would happen is, for example, if one application crashed, it didn't just crash that application, it crashed the whole process and other applications that were running with it. So it did work, but it was highly unstable. Because of one application crashing, what was happening? Other applications in the same process would also crash. Are we clear on this, everybody? So that's where now .NET has improved on this. What .NET says is that when you start on an application, the application would run in what is known as an application domain. Right? So application would run in an application domain. And what is this application domain? Right? What is this application domain? It's an area within the process in which the application runs, and the application is restricted to its own application domain. Right? Now, this is not an OS concept. This is not something that the operating system provides. Who's doing this for you? Who's managing this for you? Is the CLI. Right? Now, if you can have this, then what could you do now? How would you improve on things? Each application that starts off would now run within its own process. Right? And if something did go wrong with the application, what would be affected would be what? Not the whole process, but only its application domain. So other applications can continue to work. Are you clear on this, everybody? So again, what is the benefit here? Is the performance. You can run more applications in lesser memory. And even if something goes wrong with one application, it's not as unstable as before. So you are able to manage to run it within its own app domain. Are we clear on this? So why are we talking about app domains? Because creating app domains and managing app domains is a function of the CLI. This app domain concept will be available for .NET applications, not for non-.NET applications. So CLI will be controlling this. Are you clear on this, everybody?
Yes.
Questions, if any? So whatever I've drew some time back, same thing. So this is what was attempted earlier. Instead of running different applications in different processes, run multiple applications in the same process. But this was unstable. So what has .NET done? Within a process, you got an app domain, and the application is restricted to that particular app domain. Rather than, affecting the whole process, it only is restricted to its own app domain. So same thing that I drew some time back.
Sir?
Yes.
So what exactly does that black box of process indicates? As in, you're saying that it is given much more space or CPU usage to the application, or like what exactly does it represent?
Every application in an operating system, every time you start an application needs to be hosted by a process. Okay. And what does the process contain? Process contains details about the application. So everything that the application needs is within that process. Now the process space that is allocated, I'm saying right at the start, is far more than what the application needs. So that is what the black box of the process indicates. The process that I showed you was here. All of these are processes. All of these are processes. Right? See this.
Sir, so basically process space means memory of RAM or?
Yeah, yes.
Okay, sir.
My God, you are the Rancho of CDAC Bittu. Okay. Rajesh and others, restrict these to the break. Okay.
Yes, sir. Sorry, sir.
Maybe you meant to send it to him, but it's gone to everybody. Anyway.
Yes, sir. Sorry, by mistake.
Okay, let's go back to the previous screen. So that's app domain management, one more feature of the CLR. Okay. One more function of the CLR. Besides this, the CLR is also responsible for keeping track of something called as CLS and CTS. CLS here stands for Common Language Specification, and CTS is Common Type System. Okay, so let me explain these two terms. They are somewhat related. Let's start with CLS, or Common Language Specification. So CLS is if you want to write it down, is a set of rules. Is a set of rules that all .NET languages must follow. What is CLS? Set of rules that all .NET languages must follow. Now, again, I'll go back to one of the previous slides where I said that there are multiple languages in .NET. Right? You have over 50 .NET languages. Now, every language would have its own flavor. So what would happen is there might be some features in one language which may not be available in the other language. Right? Now, how do you then work? Because see, all of the languages are going to be compiled into your assembly code, into IL code, and you should be able to call code from the other language. Now, what would happen if, for example, I'm just giving you an example. Let's say, let's assume that VB.NET did not support inheritance. I'm just giving you an example. It does not that it doesn't. I'm just giving you a imaginary example. What if VB.NET did not support inheritance, but C# supported inheritance? Then what will happen then? The moment your code is compiled from C# code, and if VB.NET code tries to call it, it will cause it a problem, because then it will not know how to work with inheritance. Now imagine this for 50 languages, each having its own features. So how do you ensure some common ground between everybody? The CLS does that. The CLS, as I said, is a set of rules that all .NET languages must follow. So you might have some additional features, but it should not violate any CLS rule. It should not go against the CLS rule. Like one of the CLS rules is that .NET must support single inheritance only. Only single inheritance is allowed. Now, if you take a language like VC++, all right? Now in VC++ in .NET is called managed C++. So managed C++ allows multiple inheritance. But that code of multiple inheritance cannot be run by the CLR. So if you're using some code which is using multiple inheritance, you have to mark that as something called as no GC. No GC meaning that it will not be run by the CLR. So this is how the CLR ensures that all languages provide you with, a same set of features. And then it's easy to call code from one language to the other. And if some code you're trying to run, which is not CLS specific, does not conform to the CLS specifications. Now, such code, when the CLR tries to run that code, it will give you a compilation error, or not compilation, it will give you a runtime error saying that this code is not CLS compliant, so I cannot run. So when you're trying to start off an application, it first checks, is the code following CLS specifications or not? Are we clear on this, everybody? Yes. Questions, if any, about CLS? All right. Let's look at the other aspect there, which is the common type system, or CTS. Now, let's assume that before .NET, this is pre.NET, I wrote some code in VC++. So let's say I did this int do something in VC++, right? Let's just say it took an integer as a parameter and it did some code. Now I'm not worried about what the code did. Okay, so this was in VC++. And in VB6, I could actually go and call that code. I could do something like this: dim I as integer, right? And I is equal to do something of I. So I'm actually calling a function written in another language, and I'm actually calling that code, right? And let's say there's some other code in here a bit. Now, when I tried doing this in, let's say, VC++ and VB6, the moment I tried to call this code, this would crash the code. This would crash the code. And the reason for that was that an integer in VC++ was a 4-byte value. But an integer in VB6 was a 2-byte value. The moment you try to call this function and it's returning a 4-byte value, but you're trying to put into a 2-byte value, it causes the code to crash. All right. Now, this is just with 2 languages. Imagine if there were 50+ languages, each of which had its own data types, each of it had its own rules. How will you manage to do this then? How will you manage to keep track of this? How will you keep track? Okay, an integer in here is a 2-byte, integer in there is a 4-byte. If it is 2-byte, 4-byte, you need to change the value out there. So how do you keep track of that? How do you maintain that? It'll be very difficult to do so. So in .NET, how does it resolve this problem? Let's say this was C# code. And this was, let's say, VB.NET code, right? So these are, of course, .NET languages. When you take int I out here in C#, this int I is converted by the compiler to something called as int32i. So what is int here? Int is the C# language. C# language is like C, C++. So in your C, C++, how have you been used to calling an integer? All your life you've been calling it as what? As int. So you continue writing code as int. But internally, this int is converted to int32. And what is int32? Int32 is a CTS data type, a common type system data type. So this is what is being done by the compiler. Now, similarly, when you write code in VB.NET, when you say dim I as integer, integer is the VB.NET data type. This also gets converted to in32i, and which of course is now a 4-byte value. The clue is in in32. In32, 32 indicates 32 bits or 4 bytes. Are we clear on this, everybody? So now if you have code from different languages, it won't cause you a problem because the data types that you're using in .NET are exactly the same. They're not going to be different. Are we clear on this, everybody?
Yes.
All right. So which one can you use? Can I write code in here as in32i? Can I write code like this? Or let's say in32j. Can I write code like this in C#? Can I do this?
Yes, sir.
Int x, let's say. Can I do this? So both are possible. Both are possible. But as a programmer who's coming in from a C++ background, what will be easier for you to remember? What's easier for you?
Int
x, right? Or int I, whatever. So you write code like this, but the compiler is converting it to this when it goes into the I. And that allows it to be called from anywhere at all. Are we clear on this thing? So these are more to do with, working across languages, both the CLS and CTS, right? Making sure that it works perfect. So what does the CLR do with the CTS? When you're trying to call some code, it checks whether the data types that you're using are CTS data types or not. If it's not using CTS data types, it gives you an error while trying to run your code. As simple as that. All right. Let's look at some more functions of the CLR. Thread management, creation of threads, managing threads, all of that is handled by the CLR. Okay. We have a huge section on thread management. So I'm not going to talk about that right now. When we come to thread management, we will deal with it. At this point, I'm not talking about it. Right? Security management, again, making sure that your code has the requisite permissions to run. This is again managed by the CLR. Right? When you're running your code, right? Debugging the code, putting in debug symbols, making your code wait in between, all of that. Again, part of the runtime, part of the CLR itself. So again, obviously, we're going to be seeing debugging when we write down our code. And exception handling. What happens if an exception happens in your code? How does the code react? How does it jump from one place to the other? All of this is functions of the CLR. Are we clear on this? All right. So this sort of summarizes what the CLR is all about. We would be, I will be sharing it. We will be continuing with this. I'm not done with the discussion. We have a few more things to discuss, but I'm out of time for this session. So I don't want to just in a minute or two start off something and start something I can't finish. So we'll take a break at this point. We'll resume the session at 12:30, right? And continue from this point on. I will be sharing all my code and all my, whatever other things that I show you all. I'll be doing that at the end of the session. All right. So not right now. At the end of the session, I will share that. Okay. So let's take a break at this point, and 12:30 we resume again. So we're back. Let's resume from where we last stopped off. We were talking about the CLR, all right, and we talked about the functions of the CLR. We in fact discussed some of them in depth and then had a quick run through the others. Now, based on what we have discussed, based on whatever objects we have got out here, whatever things that we have talked about here, I have a question for you, right? So my question is as follows. Let's assume I am creating one of these applications. Let's say I'm creating whatever, let's say a Web Forms application, and I write some source code, right? I write some source code and I compile my code and I get my assembly. And now this assembly is on my machine. I want to run it on your machine. So I would like to copy it to your machine and, have the assembly running there. So what would I require on your machine for my code to run is my question to you.
Runtime?
I'm not saying yes or no. You all can go ahead and answer whatever you all feel. So I'm not saying yes or no. You can answer what you feel is the right answer. Yeah.
JIT compiler.
Okay.
Runtime environment.
Anything else? Any other answers? That's it. So I've got two answers actually. I got one answer which says JIT compiler, and the second one which says that the runtime. When you're saying runtime, I'm presuming you're meaning the common language runtime, the CLR. Okay. Yes. So the person who said JIT compilation or JIT compiler, the JIT compilation is a part of the CLR, right? So that's not the only thing you'll need, right? You'll need to do memory management on your code. You'll need garbage collection, app domain management, CLS checks, CTS checks, thread management, all of the things. So basically you'll need the CLR on the other machine. Now, in addition to the CLR, there's something else that you'll need, which you'll have missed out on. So what else would you need on the other machine?
So IL code?
IL code I'm anyway going to give you. I'm going to compile my code and my assembly is going to contain the IL code. So which I'm going to put on your machine. But besides that, to run it, what else would I need?
Libraries.
Correct. So remember that my code, whatever applications I'm creating, is actually calling code from the .NET base class libraries. So on your machine, I will also need to have the .NET base class libraries, right? So what I would need here is, for running my code, .NET base class libraries. And also in addition to that, I would need the CL. So these two are essential for me to run my code. Okay. Now, when you talk about the .NET framework, what does the .NET framework consist of? The .NET framework consists of utilities, like, for example, the compiler, for example, right? Plus the .NET base class libraries, plus the CLR. So what is the .NET framework consisting of? All these three things. Whatever utilities, like, you discussed one such thing called compiler. And there are, just like the compiler, there'll be a lot many more utilities which we'll come across as we go along further in our code. So one is the utilities that are there. Secondly, the .NET base classes. You require these because you're going to call code from here. And thirdly, of course, you need the CLR. So these are the three things that would go about making the .NET framework. Out of these three things, what do we need for our code to run? For our code to run, we need the base class libraries and the CLR. Okay. So generally speaking, when you are saying that, okay, if I've got an assembly and I want to install it on the other machine, the prerequisite is generally said that you need the .NET framework. On the other machine also, you need to have what? You need to have the .NET framework, which would run your code for you and which would have the libraries out here. Are we clear on this? All right. So first question was, what is the .NET framework? What is the answer to that? It consists of what? Utilities plus base classes plus CLR. Okay. Let's take another situation. Again, I'll go back to what I had. I have compiled my code into an assembly. I've got my code out here and I want to run it on your machine. But your machine is having a Linux operating system, right? Let's assume your machine is having a Linux operating system. So again, the same question, what would I need on your machine for my code to run? Yes.
I think same thing. .NET is a platform independent.
So I'm not saying yes or no. I just want to hear different responses if you have any.
So something like JVM as we have in Java.
So JVM in Java is like CLR here.
.NET libraries and CLR.
Same thing, sir.
Yeah.
Same set of things, sir.
So I'll need the same things. I'll need the .NET base class libraries and I'll need the CLR. Both of these I'll need for me to run the code on Linux. So my question is that the CLR that I have for Windows, would the same CLR work for Linux?
No.
No.
You have to install Linux CLR.
Right. Also, the .NET base class libraries that I have for Windows, will these also work on Linux? Yes.
No, sir.
No, no, sir.
So you need to rewrite the .NET base class libraries to work for Linux, and you'll need a CLR that will run on Linux as well. So the question is there one available? Right? Do you have something that works, makes your code work on Linux or not? So there's no easy answer to this. Let me explain the answer in different ways. To begin with, when Microsoft first released the .NET framework, Microsoft did not have a .NET framework for Linux. When .NET framework, it was released in the year about 2000, 2001. At that time, Microsoft did not give you a framework for Linux. They only had a framework that will work on Windows. So when they were asked about it, why have you not given a framework for other operating systems? Their answer was very simple. Their answer was, we want to promote our operating system. So we don't write a framework that will allow code to work on other operating systems. If you want the benefits of .NET, then you need to switch over to our operating system. And that was their philosophy then, when .NET was first released. But they said, if you want, then you can go ahead and create a framework for other operating systems and our code will work, because our code is in IL format. It is not a native format. So if you want, whoever wants to can create a framework for other operating systems and our code will work on that as well, was their answer. But we will not create it. Are we clear on this? So for a long time, initially, .NET code ran only on Windows. Now, when Microsoft said this, that you can put out a framework if you want to, we will not put one. There was a team of developers, not from Microsoft, who was working on creating a framework for Linux. And they did manage to create one, and they called their framework as Project Mono, M-O-N-O, Mono, or simply Mono, just Mono. Now they don't call it Project Mono, they just call it Mono. So this Mono is a framework for Linux, where the .NET base classes and the CLR has been rewritten for Linux. But it is not from Microsoft, right? It is not from Microsoft. Who's heading it? Some external programmers, people not even from any one company, all over the world. It's an open source effort, all right? In fact, the name that they gave also is very interesting. It's called Project Mono. So Mono here actually means this team was headed by a set of programmers who were Spanish. And mono in Spanish means monkey. So they named it Project Monkey, but in Spanish, of course. And why Project Monkey? Because they said, we will try to make a monkey out of Microsoft. Microsoft is saying, okay, we will not have a framework for other things. We will make a framework for Linux and allow that code. So that people who want to work on Linux can work on Linux. So anyway, so that was Project Mono. Now, what would happen is every time, let's say .NET version 1 release, Project Mono was nowhere on the picture. Now, then they started working on Project Mono, by which time .NET version 2 release. So when they came out with one of Mono, 2 of framework had come in. So there was always a gap. There was always a gap. Microsoft would release a new version and these guys would then work on it. So it would take some while for things to work out there. So all features of .NET don't work on Project Mono. All features of .NET don't work on Mono. Some features may not work, right? Now, what features don't work, you'll have to consult the Mono documentation and find out which specific feature is not working. But this is how it was for a very long time. Then around the year 2008, 2009, right? Microsoft realized that they're no longer, not no longer, but they're not, competing with Java well enough. People are still preferring to work with Java because even though Microsoft, the .NET framework gives you better performance and all, easier to work with, better features, all good reviews, all of that was fine. But the major advantage that Java had was Java would run on other platforms as well. And which Microsoft as a policy was not, purposely not doing it. They were saying, no, we don't want to sell it for other operating systems. We want to have it only for Windows operating systems. So Microsoft realized that they're losing on, ground to Java. So they took a policy decision around that time saying that we want to also come up with a .NET, implementation, .NET framework implementation that will work on other operating systems, right? So far they had never ever done that, but this was a major change in their thinking. And this version of the .NET framework that will work on other operating systems, they called it .NET Core. So .NET Core is now, of course, there are several versions later, is an operating system that, or rather, is an .NET framework that will work on other operating systems as well. All right. So they rewrote the whole framework. They rewrote it. They did away with .NET base class libraries. Did away means they rewrote the whole thing so that it can work on all operating systems. right? So this was the, sort of .NET Core out here. So when we say that our code works on multiple platforms, there are various answers to it. .NET Framework works only on Windows. Mono is not from Microsoft and works only on Linux. And .NET Core works on all platforms. Are we clear on the three different paths that you have? One is .NET Framework, one is Mono, and one is .NET Core. Any questions about this before we go ahead? It's like a history lesson actually. Yeah. Clear on these terminologies?
Yes, sir.
Yes,
So,
sir.
so we can say that Mono is .NET for Linux, right? In simple words.
Yes, but not from Microsoft. Okay. All right. So we answered this question. So let's talk about this. What are the differences between .NET Framework, .NET Core, Mono, and Xamarin? I am not talking about Xamarin, but we'll talk about Xamarin also. So .NET Framework used for Windows platform. Mono used for Linux. .NET Core used for all platforms. And Xamarin is used for mobile platforms. So iOS, Android, Windows, if you want to create applications for that, you can do so using Xamarin. Okay, that's an entirely different way of coding. It's not, others are similar. Framework, Mono, and .NET Core will have similar code, but Xamarin will be totally different. All right. Now, if you look at .NET Core, they have rewritten .NET Core. So this is entirely different from .NET Framework. They've rewritten it. First thing is they have made it open source, right? So you can actually go and see the code for the .NET Core. Then secondly, it is cross-platform, right? Cross-platform meaning it's going to work on different operating systems. Thirdly, lightweight. In .NET Framework, what do you need to first do? In .NET Framework, what do you need to first do? All these .NET base class libraries need to be already there. Need to be already there on that machine. So I told you that if you have to run it on your machine, I will need to make sure that your machine actually has .NET base classes first installed out there. Now this is a change in .NET Core. In .NET Core, your project will contain only the minimum required files for your code to run. You will not need all the files. You will need the minimum required files, whatever are there for your code to run will be included in your .NET Core. And when you install your project, these minimum files that you have, these would be copied with you along with your project. So the .NET Core will not be already there. The libraries will not be already pre-installed. In .NET Framework, what will be the difference? On that target machine, you need to have the libraries already pre-installed. In .NET Core, whatever libraries you need are there with you in your project. So you can just copy paste your project. Whatever files are required are also copy pasted with you. And that's why they have made it lightweight. They've not added too many things. Just the basic things that you require to run your code, only those are included. But they have made it extensible. Meaning what? If you want to include third-party tools, third-party controls, it's very easily available. You can download a lot of libraries that are third-party extensions. So it's very extensible. You can plug and play a lot of things. And these things can be added to your system. We'll be seeing that later in our application. There's something called a NuGet. So you can NuGet your applications. NuGet is basically a way of copying what you require, whatever files you require, it sort of installs it on your system. So that is the extensible part of it in .NET Core. Right. So what is the difference? The philosophical, I mean, how is it different out here? In .NET Framework, the files will already be there on that machine, and you have to go and install your project. So your project will be small in size. In .NET Core, what will happen? Whatever files you require will be included in your project. So your project will be larger, but the target machine doesn't need to have any files in place out there. So that is how, you know, things will be different in .NET Core. Right. So we will be looking at .NET Core also. I mean, both. We are looking at your course actually dictates both, that you need to know .NET Framework and .NET Core. From a coding perspective, a lot of things are similar. From a configuration perspective, things will be slightly different. Okay. All right. Talking about .NET Core, again, you know, we are see, each one has its own journey. There are different versions in each one. So .NET Framework has its own versions, Mono has its own versions, and .NET Core has its own versions. So up to version 2.2 of the .NET Core, you didn't have too many project options available. It only supported ASP.NET MVC and Web APIs. So you could create Web APIs and ASP.NET MVC applications only in .NET Core version 2.2, up to 2.2. Remember on one of the earlier screens, I've shown you that there are different application types. So all of those were in .NET Framework. But .NET Core is specifically this. Version 3 onwards, they have also included support for WinForms and something called as Windows Presentation Foundation. So WPF and WinForms are for desktop applications. So up to version 2.2, they didn't have support for desktop. Version 3 onwards, they have support for desktop applications. Right? Now, after, you know, the .NET Core, they did .NET 1, .NET 2, I mean .NET Core 1, .NET Core 2, .NET Core 3. After .NET Core 3, they skipped a major version. And they didn't have a .NET Core 4. They directly jumped from 3 to 5. So .NET Core 1, 2, 3, 5. And then 6, of course. Now, why have they done that? What is the, you know, again, the versions again have their own story. So what used to happen was you would have different versions. So you had .NET Framework version 1, .NET Core version 1, .NET Framework 2, Core 2, .NET Framework 3, Core 3, .NET Framework version 4, 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8. Now, when they came to 4.8 in .NET Framework, they said, we will now not do any new development in .NET Framework. This is the last that we are doing in .NET Framework. So .NET Framework, there is going to be no version after 4.8. That's end of the road for .NET Framework. They're saying all new development that we're doing will be only done in .NET Core. Are we clear on this? So .NET 4.8 is the last version of .NET Framework. It's not going to go up further. Now, in the meanwhile, .NET Core 3 had come, and to avoid confusion, they said now, after .NET Core 3, we don't want to bring in 4, because again, then 4 and 4 of Framework, 4 of .NET Core, again, there'll be confusion. So we'll skip 4 and we'll jump to 5. We'll jump to 5. So what is 5 actually? 5 is .NET Core 5. 5 is .NET Core 5. But there is going to be no .NET Framework 5. Framework has stopped where? At
4.8.
4.8. So what they are saying is .NET Core 5, we will call .NET 5. We will not use the word core. Why will not use the word core? Because there is going to be only one .NET 5, which is .NET Core 5. So they have dropped the word core from .NET 5 onwards. So .NET 5, and then now, of course, this release about 7-8 months back, .NET 6. So both of these are .NET Core actually, but they're not using the word core. Are we clear on this, everybody?
Yes, sir.
So these are the history of the different versions that are going along, and which is why there is so much of confusion. 1 second. Charging was off, so I had to switch that on. All right, now where are we in terms of CDAC? What are we going to do? Because there are so many different options available out here. So the CDAC course is actually decided a few months back, right? I mean, you all have started your course about 4-5 months back, whatever. So even though there might be later versions released, CDAC, sticks to what they have announced when the course was announced. Okay, they don't change that in midstream. So here is what we'll be covering in CDAC. The software that you need would be Visual Studio 2019 Community Edition. I hope all of you have installed this.
Yes, sir.
Yes, sir.
Yes, sir.
All right, so this is the one that we'll be requiring. I don't want 2022. I want 2019 Community Edition. Is that the one that we have, everybody?
Yes, sir.
Yes,
All
sir.
right, okay. Framework 4.7. Now 4.7 and 4.8, there are negligible differences. So 4.7 and 4.8 is exactly the same, actually, almost exactly the same. Just some minor differences. The language that we're going to be working with is C#, right? So we're going to first look at .NET Framework, and then we are going to also look at .NET Core. Both of these we're going to look at. So why are we looking at both? What is the reason for doing both? I mean, most of the things that are decided as CDAC are aimed at how to make you more placeable. How to what course can we cover that gives you maximum scope for placement. That is their objective. So what is happening is a lot of companies have not yet switched to .NET Core. They're still having .NET Framework projects, right? And then this number is changing. I mean, maybe 6 months later, that would be not the case. But at this point, still companies are still working with .NET Framework and .NET Core both. So, which is why you're going to be taught with .NET Framework to begin with. Now, a lot of the things that you're doing in .NET Framework will also work with .NET Core. It's not that they will not work. They will also work with .NET Core also. Basic concepts will be exactly the same. There will be some advanced features of .NET Core which are obviously slightly different. So we'll cover an intro to .NET Core and focus on .NET Framework. So these are the things that you'll be doing. The good news is that if you work with framework, then .NET Core is not much different. I mean, you can pick it up on your own also. So that's not really going to matter much for you, right? Now, within this, the types of projects that we'll be working with is listed out here. So we'll be working with initially something called as console applications, where it's like a dark screen. Like I said, I don't like it at all, but that's the one that we're going to be working with. Where you will learn C# syntaxes and basic object-oriented concepts. So these are, which are used in .NET. So there will be minor differences from what you're doing from Java to here. Things will be slightly different, the way in which it worked in Java to the way in which it worked in .NET. So we'll be focusing on those things first. Then our major area of development will be in ASP.NET MVC. That's where we'll be doing most of our, coding, so to say. And then web services, WCF, web APIs, all of these are creating services. So these are the types of projects that we'll be looking at out. All right. So over the next whatever 2.5 weeks is this what is planned for you. Are we clear on this, everybody, on what is the path ahead in terms of what we need to do?
Yes. Yes, sir.
Yes.
A few terms that I want to explain to you before we actually get into any code. I'm itching to get into code, but I want to cover these few things first. So you'll often come across a term called managed code and unmanaged code when you're working with .NET. So any code that you write in .NET, will be run by the CLR, right? And all such code is called as managed code. Why managed? Managed by the CLR. So all code that you're writing here in our training session is all going to be managed code. We are not going to write any unmanaged code. Okay. The other type of code that you can work with is unmanaged code. Now, this is mainly code that was there before .NET. So before .NET came in, you could create, some type of software. So what are the two main types of software that you would create? You would create either Windows DLLs. You would either create that, or you would create COM applications. This is before .NET. Now, they have kept backward compatibility for these applications. So you can go and call code from here, from Windows DLLs or from COM applications. But when you call code from these type of applications, this code is not run by the CLR. They will have their own runtime. This will not be the CLR runtime. It will be totally different. And all such code is called as unmanaged code. Unmanaged meaning CLR has nothing to do with this run. So you can call such code from .NET, but CLR will not run such code. All right. The examples of unmanaged code are Windows DLLs, also called as platform invoke services, or in short pinvoke. That is one example. And the second one is when you're calling COM applications, and then the term here used to deal with this is COM interop. So you can actually call COM code from here. All right. So key takeaway for you in here is what is managed code. So what is managed code? One word explanation or one phrase explanation for managed code. Code that is
Run by CLR.
run by the CLR. All .NET code. All .NET code. So later you will come across this term, something called a managed provider, for example. So the moment you hear word managed, it means that CLR is going to run that code. Right? Okay. One more thing that I wanted to talk about was what goes into an assembly. What is the structure of an assembly? Remember on the earlier slide, we talked about what? When you write any code and you compile the code, what are you getting out here? You're getting an assembly. So assembly is in IL format. I mean, the code in there is in bytecode IL format. But we are breaking this down further. We are talking about what is there exactly inside an assembly. So these are the things that would go into an assembly. Supposing you have created an assembly, let's assume myassembly.dll. So one part of it would be the code. So that is something that we have talked about. So MSIL code would be one part of it, right? But in addition to that, details about the assembly are also stored in the assembly itself. So everything that you wanted to know about the assembly is present in the assembly itself. Right? Now, what are the things that you would be having in the assembly? One thing you will be having there is an assembly manifest. What is the manifest? Another word for manifest.
Rule book?
Sorry.
Rule book?
No, it's not a rule book. It is a list. A manifest is a list. Have you heard about a passenger manifest on an airline? A passenger manifest. What is a manifest? Nothing else but a list. So when you're talking about assembly manifest, it's a list of things about the assembly. A list of properties about that assembly. So what goes into the manifest? Details like name of the assembly, the version number of the assembly, all right? The culture here is used for creating multilingual assemblies. So you can have different cultures for an assembly. Like, let's say maybe English-US, all right? EN-US could be one culture. Or Hindi-India, HI-IN could be another culture. And at runtime, you can change the culture and change the language that you're showing in that assembly. So, you could create multilingual software out here in .NET. Right? So that is part of the details about the assembly. What is the culture of this assembly? Then strong name. Again, we'll be looking at this a little later. At this point, I don't want to get into strong name. But basically, it's a name used to uniquely identify an assembly. Right? The list of all the files contained, list of references. I'll explain to you references. All of this may not make a lot of sense right now. Right? And type reference. Type reference is any other type. Another word for type is a class. So what other classes are you using in here? So this is the assembly manifest. So basically, what is the assembly manifest? Details about the assembly. All the details that you need to know about the assembly are part of the manifest. Besides the assembly manifest, type metadata. Another word for type is class. So the metadata about a class. Metadata meaning, another word for metadata. What do you mean by metadata? Yeah. Metadata.
About data.
Data about data.
Data about data.
Okay. So I must have asked this question 1,000 times, and 1,000 times I've got the same answer. What is metadata? Data about data. So what data are we talking about? When we say class metadata, it's basically details about the class. Things like what are the members in the class? What are the different methods? What are the different variables, properties in the class? If you take a method, what are the parameters to the method? What is the return type of that method? So something that describes the class in detail is your type metadata. So this is also part of the assembly. And you can read this metadata programmatically. Programmatically, you can read this metadata, all the metadata of that assembly. And reading the metadata of an assembly is called as reflection. What do you mean by reflection? Reflection is reading details about that assembly. So you're reading the data of that metadata of that assembly. So why is it possible to do that? Because all the details that you need about the assembly are now part of the assembly itself. So in addition to the code, you have details about the assembly. You may also have resources. Not all assemblies have resources, but it may have resources. So resources are extra files that store information about things that might be used in the program. So if we are doing multilingual assemblies, I will talk about resources then. At this point, of course, I'm not talking about it. But you can have resource files, RESX files, resource files, which store, details that will be used in your code. So bottom line is everything that you need to know about the assembly is part of the assembly itself, which is why in .NET framework, for example, it allows you to do Xcopy deployment. What do I mean by Xcopy deployment? Xcopy deployment means I can just copy my assembly to another folder, another place, and my assembly is deployed. as opposed to what used to happen before in .NET. Before .NET, you had COM. So I couldn't just copy a COM program there. I had to install it. Remember, we talked about DLL hell. And we said that if you have a COM application, that needs to be installed on the registry of the other machine. So all details about your COM application used to be installed in the registry. As opposed to that, because there were problems with that type of approach, in .NET, what have they done? They have said everything that you need to know about the assembly is in the assembly itself. So you don't need to store details about the assembly anywhere else. The assembly becomes a self-describing unit. And it allows for, the term used is Xcopy deployment. Xcopy deployment is just simply copy paste the files and your application is deployed. Okay. All right. So these are some of the key concepts that we discussed and we talked about. Many more concepts, but we'll take it along with the code. It will become very boring otherwise, just to talk about concepts. So we'll jump into the code at this point, and we will, as I said, my focus is going to be on code. So we'll learn concepts along with code. Right? Okay. Now I don't always take a online session. I don't do that. But for the first session only, for this session only, I would like you all to code with me. Okay. So I'd like you all to, whatever I'm doing on my machine, I'll go at a slow pace because I'll be talking a lot. I'll be coding less and talking more. So I'd like you all to do this with me, open up Visual Studio with me, and we will work on this together. All right. So please open Visual Studio 2019. All right. Now, if it's the first time that you're running it, it will ask you for, it might ask you for registering Visual Studio. It might ask you for that. So there's an option there which says that remind me later or register later. So you can say register later. Okay, if it shows you a dialog box prompting you with that. Another dialog box would come up which would ask you for what are the default settings you want to pick up. So, you can customize the way in which Visual Studio looks. So you can give that as the default settings. The general settings option is there. So whatever the default options out there, you can just choose that and just say okay and carry on. All right. Once you're past those first two steps, you'll be shown a screen similar to mine, but with a slight change. On the left-hand side, this area would be blank for you. This, what you're looking at here, this area will be blank for you. So it will show you on the right-hand side something like get started. Okay. So are we all on this screen?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now, let me take you through the right-hand side, what you need to do. First option here is clone a repository. If you're having files on GitHub, you can sort of get those files onto your local machine. All right. So we are not doing that option right now. So we're not using GitHub right now. So leave that for now. So don't go into that option at all. Second option is open a project or solution. So if you have an existing project that you have worked with before, you can open that project that has already been worked on. So obviously we don't have that right now. Now I will be at the end of my session sharing my files with you. Right? So if you want to open my files, if you want to look at my files, which I'm sharing with you, you will go in for open a project or solution. All right? I will explain to you the difference between a project and a solution and what it means. But for now, if I share some files with you, this is the way in which you will open them. There's an option, next option here, which says open a local folder. Don't ever use this. Do not use this. I wish there was a way of removing it. I would have asked you to remove it. Do not ever use this. All right. The reason why I'm telling you this, because when it will allow you to open also. But when you open it this way, your code will not work the way it's supposed to. So don't open a local folder at all. Instead of opening a local folder, what should you always be doing? Open a project or a solution. All right. All right. Now, at this point, of course, we don't have any. So we're going to go in for creating a new project. Whatever code that you write will be written in classes. Right? Whatever code you're writing, it will be written in classes. These will be saved in a .cs file. Whatever classes you're creating will be saved in the .cs file. CS short form for CS.
C sharp.
Right? So all your code will be written in the .cs file. Now you might work with 3-4 files together. These different files will be put together into one project. So one project will contain multiple files. Each file can have different classes in them. The project will have an extension of .csproj. CSPROJ will be the extension for the project. When you open a project, it will open all the .cs files that are there in that one project. Understood? So one project can contain multiple CS files. Each CS file can contain multiple classes. You can open multiple projects simultaneously. There will be situations where you will need to work with more than one project at the same time. All the projects that you open simultaneously will be put into a .sln or a solution file. So there will be a solution file, there will be a project file, and there will be a .cs file. Are we clear on this, everybody? When you're opening this, what are the options I'm asking you to open? What is the option that you have to open?
So either open a project or create a new project.
No, I'm saying if it's an existing project. Now, creating a project is different. I'm saying for opening an existing project. Let's say my code you want to open. What are you going to open?
Open a project or solution.
Open a project or solution.
What is the project file name extension?
.cs.
Not .cs.
CS proj.
.cs proj. PROJ. What is the solution file extension?
.sln.
.sln. So these are the only two files I wanted to open. Do not double click on .cs file. .cs file is what is your code file. Do not double click on that. Do not open a local folder. It will cause you a lot of problems. Are we clear on this, everybody?
Yes, sir.
Yes, sir.
You can open only a .sln file or a .cs proj file. I'm spending almost now 10 minutes talking to you about this. But in spite of this, I can promise you there will be some geniuses who will go and open a folder or go and open a .cs file. So please don't be that genius. All right. Okay. Right now, we're going to go in for creating a new project. So click on create a new project. Now in the second screen that you see, you will not see anything out here on the left hand side. This area will be blank for you. Right? So why is it showing me? This is recent project templates. Projects, different project types that I have worked with already. So I have worked with a lot of them. So that's why it's showing it to me out here. For you, it will be blank right now. Look at the right hand side. There are three options shown here. First is which language do you want to code in? So we want to code in C#. Select that as C#. In case it shows you all languages, please change that to C#. Secondly, what platform or what operating system you want to target. If I'm going to work with .NET framework initially, what should I be targeting?
Windows.
Windows. So .NET framework can only work on Windows. So make sure that this is kept as Windows. And thirdly, you have the project types. So there are different project types. Initially, I'm going to start off with a console application. I told you that our application, our focus will be on creating classes, learning syntaxes. So we don't want to work with UIs where UI concepts come in. We are going to work initially with only with these type of projects. So once I've chosen this, now you get two options out here. Ignore the third option, ignore the workflow. You get two options shown here to you. First option is console application. The second one says console application into bracket .NET framework. So what are the difference between these two? The one which says into bracket .NET framework will only target Windows, will only work for Windows. And that's the one that we're going to work with first. There will be slight differences in concepts and we'll highlight them later. But initially to begin with, that's the one I wanted to select. Console app into bracket .NET framework. The other one, which says console app, this is for .NET Core. All right. So that's the one that I've selected. Until I tell you to, you're not going to change the project type. I will tell you 1 or 2 days later, I will tell you now we will change the project type. Till then, whatever projects that you're working with will be in the same project type. Right? Click on next. First thing is the location. I'm going to ask you all to change the location. Given a folder that you all can recognize later, you all can easily identify later. Right? So I'm creating a folder here called JK July 22, which is where all my files will be saved. Please identify a folder. I don't want your files all over the place. So at the end of my training, you should be able to pick up that one folder and all your files will be in that one folder. Right? So select any folder on your machine and identify it and remember it for next time. I don't want you to tell me, when I tell you, please show me the code, sir, I can't find the file. I will throw something at you through the laptop if you can't find your file. Okay. All right. Now here it's asked you for three things, in fact. First thing is what framework do you want to target? So pick up the latest version of the framework, 4.8 you can pick up. I'm picking up 4.7.2 only because there might be some people for whose code it will, it's not got the latest versions or whatever. So I've taken 4.7.2, but you can take 4.8 as well. There are very little differences. Basically, almost no differences between the two. The solution name and the project name, two things it's asking you for. I'm going to call every day that I work with, I'm going to give it a different solution name of day 1, day 2, day 3, day 4, and so on and so forth. And then the project name should vary depending upon the project that I'm creating. So let's say I'm calling this as basic class concepts. Okay. So solution day 1 and project name basic class concepts. So where would this be created? It will be created, in my case, d:/trainings JK July 22 / day 1. And under that day 1, there'll be another folder called basic class concepts. All right. You'll also have a .sln file called day1.sln and a project file called basic class concepts.csproj. So those are the files that you need to open and create. Right. So it takes a couple of seconds to create the project. Right. All right, and it comes with some, standard code that it has generated for you. Can you close this window, the program.cs window that is showing up out here? Look here at my screen. Can you close this window? All right. And on the right hand side, if it is showing you anything else, close any other windows that you have till you get a gray screen like this. You get a blank gray screen like this. So close any other windows that you might have. Okay. So what we're going to do is we're going to start off with trying to see what if you're going for a new project and what if nothing is shown to you, then how do you get everything back? So sometimes you might close a window. How do you get that window back? How do you navigate through all of this? So the starting point of all your navigation is the Solution Explorer. So go to the View menu and choose Solution Explorer. View menu and Solution Explorer. As the name suggests, it shows you your solution. So do you see there right on top, Solution Day 1, right at the beginning? Right? Solution Day 1, one of one project. So right now only one project is loaded, but if you add more projects, these would be shown up there. Below that was basic class concepts. What are that? Basic class concepts?
Project name.
Project name.
Right? All right. Below that, you have properties for this project. You have properties for this project. Double click on properties. Double click on properties. Right? So it opens a window where one of the things, there are a lot of properties there, but one of the things out there is assembly name. Do you see that? Assembly name right at the beginning? Right?
Yes, sir.
All right. Then there's a button out there which says assembly information. There's a small button in the middle of that screen which says assembly information. Click on that button and it opens a further window for you. Now, one of the things that is shown there is the assembly version. So it's 1.0.0.0, right now. So what is all this that we are seeing? I've shown you assembly name, assembly version. What is all this that we are seeing? What is this?
Manifest.
It's not manifest, doesn't contain all this information. Name and version will be there in the manifest, but not all the information. Basically, assembly metadata. Details about the assembly can be all stored out here. Okay. If you are in that assembly information window, you can cancel and come out. And if you are in that basic class concepts window, you can close that window and come back to the that gray screen that you see out there. So information about the assembly can be edited from the properties, and we will do that in later examples, not right now, but later examples we will need to go and change that. Okay. The second option that you see out there is something called as references. Okay. Now, in Java, if you have to use an external package, what do you need to do?
Import statement.
You need to give imports and that package name. Only after you give imports can you use that package. Correct?
Yes, sir.
In .NET, if you have to use an assembly, you have to add a reference to that assembly. So the term here used in .NET is what? Is add a reference. So you're adding a reference to that assembly. Can you expand the references? Can you expand on the references? And you'll find that there are some references shown for you by default. So these assemblies have been included for you by default. All right. Let's go and add a new reference. Let's go and add another reference. So right click on references. Right click on references and choose add a reference. Choose add a reference. right? A dialog box is shown to you. On the left-hand side of that dialog box, there's a tab called Assemblies. Can you please click on that tab for Assemblies? Okay. And what you see here under the assemblies are all the .NET base class library assemblies. All these libraries that you see are all the .NET base classes, base class library. So you can select one from here if you want to. Okay, we don't need to select anything right now, but be aware of this, right? Okay, now if you are creating your own projects and you want to add a reference to not .NET based classes, but projects that you have created, assemblies that you have created, those would be listed under projects or shared projects. Okay. Similarly, if you wanted to use COM libraries, it will be available under COM on the left hand side. So these are different things. So we'll not be looking at all of them. We'll be looking at assemblies and projects, right? Cancel this and come out. Cancel this and come out. All right. The third file that you see out there, the third option that you see there is something called as app.config. Any guesses what that would be? App.config. Yes, the name itself tells you.
Configuration file.
It's a configuration file. So any settings about the application can also be given here in the configuration file. So we'll see this also in further sections of how to use this config file. For now, I'm not using this. I mean, we're going to do a hello world example, so we don't need to do all of this right now. And then the fourth thing out there is program.cs, right? .cs is your actual code where you're storing the code. So double click on program.cs, open program.cs. And that is what was shown to you sometime back. Okay. So anytime you want to open a file, look for it in the Solution Explorer and open it from there. Okay. All right. Now, there's a lot of information that I want to throw at you. There's a lot of things that I want to do, but let's first just get that curiosity out of your head. Let's quickly just do a hello world program so that you can be happy that you've written one line of code at least. And then I'll give you the explanation of what we're doing in there. So I'll explain all that later, but you see a static void main, right? You see a static void main. Look here for a second and then you can attend the same. I want to print a hello world on, on the output window out here. So to do that, I'm going to type out system.console.writeLine and WriteLine has multiple overloads. One of them takes a string as a parameter. So hello world. So this is what I have done. Right? Okay, now if I run this code, look at this code. If I run this code, there are two ways of running the code. One is start debugging and the other one is start without debugging. See what happens if I do it with start debugging. If I run this code with start debugging, look at the screen. When you run it with debugging, the window appears and disappears almost instantaneously. So you don't get a chance to see what has happened in your code. But if you try it with the other option, debug and start without debugging, after running the output, it prompts you press any key to continue. Right? So that's what you can do out here. Write down this line of code and run it with what? Without debugging. What is the shortcut key for that? Look at the shortcut key.
Control F5.
Control F5. So try this out quickly, get your hello world out of the way, and then we'll discuss more in detail what is happening. Okay, a minute to do that. All right. Hopefully you'll have got that working. Is it? If it's showing you the output, right?
Yes, sir.
Now let's go a little bit deeper into what is happening out here. Let's see how this code is running, what it is doing, and so on and so forth. All the code that we wrote, main was my startup point, static void main was the startup function, which was part of a class, and the class itself was part of a namespace. So why do we need a namespace? What's the reason for having a namespace? Yes.
Run the specific code.
All right. So the namespace that you create out here is just used to organize your classes better. Classes that are of the same type or that are related to each other in some way will be put into one namespace. So for example, I could do something like this: public class, class 1, right? Or public class, class 2. So whatever classes that I'm creating can be put into different namespaces. So let's assume class 1 and class 2 are related to each other. They will be put into the same namespace. A namespace can contain either classes or other namespaces. So let's say I'm having N1A, let's say, right? And let's say I have another class out here, public class, class 3, right? I could have either classes within a namespace or other namespaces out here. Now to refer to this class, I will refer to it as namespace dot class name. So to refer to class 1, I will refer to it as what? As N1 dot, yes, class 1 or N1 dot class 2, right? That's how I could refer to it. Now if I have to refer to class 3, I will refer to it as what? How do I get to class 3?
N1 dot
N1 dot
N1A
N1
dot
dot
class 3.
Correct. N1 dot N1A dot and then class 3. So it helps you organize your classes better. It allows you to, related classes are grouped together and put into one namespace, and allowing you to simply, instead of having all the classes together, you can actually say that these classes which are of certain type are into one namespace. Are we clear on this? So you can create namespaces here. So it's created a default namespace called basic class concepts, and which has a class program. Now let's pay attention to the line of code that we wrote. Okay. To begin with, 2 minutes, just look here. Don't worry about typing it out. Just look here. Let me comment out this line. And let me write down this line again. When I'm starting typing this line, see what happens. When I start typing, it's showing me IntelliSense. Okay. Now I'd like you to follow this IntelliSense. So which means, when you type it out, first thing is system. The moment you come down to system, stop typing. Don't type out more. I'll show you that again. Supposing I started with typing out system. Now if I got SY, what do I have there? It shows me system already. The moment you reach there, stop typing further. Do not type out anything else, because you got what you wanted. You wanted system. What is system here? Look and tell me. It's there on the screen. Tell me what is system.
Namespace.
It's a namespace. Where did he get the answer from? Where did he know the answer from? From here. So it's showing you what system is. System is a namespace. All right. Can you identify a namespace out here? If you look at this symbol here, what is the symbol for? The symbol is a symbol for a namespace. Now these symbols are very useful in you understanding code. All right. So for example, if I'm typing out this N1 also is what? It's showing you curly brackets, empty curly brackets. So that's your namespace out there. So when I'm typing out system, for example, it's showing you whatever things are there are actually shown to you accordingly. Are we clear on this, everybody? So can you, by looking at the symbol,
sir.
identify the namespaces here? Just by looking at them, can you tell me which are the namespaces here? Yes. Can you figure out the namespaces here? Supposing I start typing out S. Are any of these namespaces?
No.
No, sir.
No, sir.
How did you know that?
Curly
Curly
bracket.
bracket.
So if you identify that, it should be able to give you what the what that particular object means. Now namespaces don't have any code in them. What do they contain? Namespaces contain either other namespaces or classes, right? So they won't have any code. So you can't just leave an object of type system and that's it. You would need to have system dot something. So now when I'm typing it out, look at what I'm doing again. I'm typing on SY. I am not typing out the rest. I want system dot. After this, I'm directly typing out a dot. And what does it do for me? It completes the word and shows me the further things out there. So these are all the things that are there under system. All right. Can you identify namespaces here now very easily? Under system, what are the namespaces that you can see?
Component model.
Component model.
Right? Anyway. So we didn't want that. We wanted console. When you start typing console, see what happens. You start typing console and it shows you options here. Again here, do not type it out. Do not type it out. Instead, what will you be doing? You want system.console dot. So you just press a dot after this. But before you press a dot, what is console? Can you tell me what is console? Look there and tell me what is console.
Class. So it is class inside system namespace.
Right. So how do you know it's a class? The IntelliSense is showing it that to you. Class system.console. Looking at the symbol, can you identify other classes in there?
Cancel event.
Console cancel event tags. Any other?
Context bound
object. So even by just looking at the symbol, you should know what that object is. So as you learn more and more, Visual Studio will tell you everything that you need to know. You don't need me at all. You seriously don't need me at all. Visual Studio is giving you all the information that you need. Right? But don't tell that to your management. Right? Don't tell them that you don't need me right now. Anyway. So system.console, that was a class. Dot. Now look at right line. It shows you, if you type out the first character, it will show you right line. Void console.writeLine. What does that look like? Void console.writeLine. What is this? It's a method. So identify other methods out here by looking at the symbol. Any other methods that you can see?
Right
and right line. Okay. All right. Now look at the right line. If it's a method, you will need to give in parentheses. Any method you always call with parentheses. Look at the parameter that it's taking. What is it taking?
String.
String value and plus 18 overloads. So that means there are 18 other options that you can give out there besides string value. Okay, let's explore them. Again, no typing code. No typing code. What are you going to do after this again? Yes.
Let's dot.
You get a dot after that. Are you going to do right line dot? No, it's a method. It's a method. Then what will you do? Parentheses. Parentheses. So do not type it out. Again, I'm telling you, please do not type it out. Right line gives you this. And then there are 19 possible ways in which you can call right line. So if you're using it for the first time, you can go through that. What are the different options that you can actually pass out here? Okay. What did we want? Of course, out here we wanted a string which took up hello world. All right, and then semicolon, of course, to complete. So why am I asking you not to type it out? Because while typing it out, you might do something like this. And it's not coming. Why is it not coming? Why is it not coming?
System spelling.
There's a spelling mistake. Okay. Or you go and correct it also. Why is it still not coming?
So not following proper naming convention.
Yeah, because it's uppercase and lowercase is different. So eliminate all errors in your code by not typing out code. I do not want you to type out code. I don't want you to be a good typist. I want you to be a good programmer. Are we clear on this, everybody? No mistakes this way.
Yes, sir.
All right. I'll do it one more time. One last time. What do you do? sy dot console dot right line open parenthesis complete what you want to do. Right? That's how you're going to be writing down. Are we clear on this, everybody?
Yes, sir.
Yes, sir.
Go ahead and try this out. Do the same right line again. Yes, it's case sensitive. Okay, no direct messages to me. Huh? I am not going to take any direct messages. Whatever messages you have to be put on the group. And what did I tell you? Preferably what? Preferably what? Don't type. What? What do you do?
Speak.
Speak up.
Yeah. Saurabh, is your mic on?
Yes, sir.
So speak next time. No typing.
Sorry, sir.
All right, done. I wanted to get used to typing it out that way. All right. Okay, let's try something else. Now you'll find that this code of yours works even if you don't give system. All right, even if you don't give system. So if I run this code now, this works just as before. Okay, I press F5. I should have pressed Control F5. Right? So it shows you the output as before, even without giving system dot. So why does it work without system dot as well? That's because of the using statement out here. Okay. Now, here is one major source of confusion for y'all when you all switch from Java to .NET. In Java, the import statement does two things. It imports the package that you want to use. It allows you to use that package, and it also shortens your code. Right? So in Java, the one import statement is doing two things to you. In .NET, this is not the case. In .NET, how do you include an assembly into your project? What do you need to do to include an assembly into your project? Yes?
Add
No?
reference.
Correct. Add a reference. We saw that some time back. So if you want to include a library into your project, you need to add a reference. If you don't add a reference, you can't use it. Now, after adding a reference, only after adding a reference, the second thing that you can do here is you can shorten your code by giving a using. So here, the way in which it works is it first checks, is console a class in the current class? So do we have a class called console in the current class? Quick yes or no answers. Do we have a class called console inside the current class?
Yes, sir.
No.
There.
Yes, sir.
Have you defined a class called console in the current class?
No.
No, sir.
No, sir.
No, there is no class called console in the current class. So second possibility is there a class called console in the current namespace?
No, sir.
No.
sir.
No. So if it's not there in the current namespace, then look for it in these namespaces. So is there a class called console in any one of these namespaces?
Yes.
Yes.
In which one?
System.
Using system. So what if I remove this using system? What if I comment out using system? Will this work now?
No.
sir. Showing
No, sir.
So what is the solution? Would system.console.writeLine work?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
This would work because you're giving the whole path,
Yes, sir.
Yes,
right? Or the second possibility is what? You go and give a using on top. Now see how the Visual Studio helps you. If this happens, if this sort of error occurs, see what I can do. It says the name console does not exist in the current context. Current context means what? What is the current context? Either the current class, all right, or the current namespace, or the namespaces that you give out here. So that is the current context. So what you can do here is you can go into show potential fixes. And in the potential fixes, first option here is what? What can you do? How are they suggesting you solve the problem? What are they suggesting?
Using
Put in the using system.
use system names.
So if I give this option, it generates the code for me for using system. All right. Let's do that again. Supposing I said show potential fixes and I said using system. So what does it do out here? It generates that code for me. Second possibility, what did it say? What are the other option here? What are they saying? Change console to what? System.console.writeLine. Even that will work. So even that will eliminate your error. All right. Third possibility, generate a variable called console. So generate a variable called console. Now, this is what it has done out here. So now console is getting solved, but WriteLine is giving a problem. So was this a correct way of doing things?
No.
Was this solution correct?
No.
Yeah. Is this what we wanted? We wanted to create a variable of called console and then use that variable. Is that what we wanted to do? Answer is no.
No,
So this is not the correct solution to this. Look at the other option there. Generate a type called console. So if you generate a type called console, what is it doing here for you? Creating a class called console. Now, is that what we wanted to do again? Yes.
No, sir.
No, sir.
So when you're seeing the solution, don't just randomly click on any solution. See what they are offering you on the right hand side. See what they are offering you on the right hand side. Right? And if that is what you think you need to do to solve it, then use that option. Otherwise, don't just randomly click here just because the option is given to you. All right. So I'll keep it back to the using system option on the top. All right. Now, we saw we could run it without debugging. Now, when you run it without debugging, the problem is that you will not be able to debug your code. And as we go along and as we write more complex code, we want debugging to be there. So we want to run with debugging. But when we do this, what is happening? It's not waiting for you to see the output. So to make it wait, I'm going to give a console.readLine. and the read line will wait for me to press enter before the screen exits. So it's waiting for me to press enter. Now only when I press enter will the program end. So when you're running your code, I do not want you to run it with start without debugging. I want you to run it with debugging. And to enable you to see the output, we will keep a console.readline. All right. All right. So anyway, we are almost out of time. I'm stopping the lecture here.
Okay, sir. Yeah.
But what will you do in the lab? There's nothing to do in the lab. Agree? Whatever we're done together out here. So what will you all do in the lab today? Yes?
Revising the concept, whatever we learn.
There are hardly any concepts. The earlier things was all theory. Lab is for practice. Lab is not for reading. So what are you going to do in the lab today? Answer is nothing. Right now you have nothing to do. So I will join you for a short while in the lab and I will take a session to begin with. I will take a short session in the lab time. So all of us stay. I know you all normally disperse to different labs and whatnot, but stay, Nisha, if you can, they can all stay in one lab or one classroom, wherever. Tell me where to join. Same link.
The same link, sir.
Yeah.
We'll join the same link at 3 p.m.
Yeah. So join the same link at 3 p.m. I'll take a short session. I don't want to take a whole session, but enough for you to try out a few things. Otherwise, we have hardly done anything out here. All right. So see you all at 3. We'll continue at 3. Right. Bye for now.
Yeah.
Yes, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.